In 1977, NASA launched Voyager 1. Nobody expected it to still be alive today, more than 15 billion miles from Earth. The probe was designed to tour Jupiter and Saturn, then drift quietly into interstellar space until its power ran out. It should have been nothing more than a faint, dying signal. Instead, nearly 5 decades later, it picked up something no one saw coming. Voyager's plasma wave instrument detected a disturbance. At first, it seemed like the usual cosmic noise, random hisses from radiation and particles. But when scientists analyzed the data, the pattern looked different. It wasn't chaotic, it wasn't random, it was rhythmic, smooth, almost like ripples moving through water. That made no sense because in the emptiness of interstellar space, there should be nothing to create such waves. And if that sounds unbelievable, just wait. Because what Voyager uncovered next doesn't just challenge physics. It forces us to ask whether we're really alone out there. So before we dive in, hit the like and subscribe button, because this is a discovery you won't want to miss. The strangeness becomes even clearer when you remember what Voyager really is. Its computer is weaker than a pocket calculator. Most of its instruments are already shut down. Only 2 remain active, the plasma wave detector and the magnetometer. Its transmitter radiates just 23 watts, weaker than a household light bulb, and yet across billions of miles, Earth still hears its signal. Against all odds, this old, underpowered machine recorded something that the most advanced modern telescopes never noticed. In fact, the irony is striking. Modern observatories use complex filtering systems to separate signals from noise, but sometimes complexity hides what's really there. Voyager, built with 1970s simplicity, doesn't overprocess, it just listens. And that may be why it caught this anomaly in the first place. Normally, plasma instruments pick up scattered bursts of energy as charged particles fly through space. The recordings sound like random pops and hisses, the natural static of the universe. But what Voyager detected was nothing like that. It was clean, sustained, symmetrical, a signal with structure, not noise. This is where things get even more unsettling. The data looked as though something had physically displaced particles around the probe. In other words, the plasma wasn't just reacting to energy, it was being pushed aside, like a solid object was moving through it. The ripples it left behind weren't chaotic, they were precise, almost engineered. To picture this, think of how a boat cuts across a lake. The water ripples outward in an ordered pattern. Voyager's readings suggested something similar, but there's no lake out there. Interstellar space is supposed to be empty, with particles so sparse that they rarely interact. And yet, Voyager recorded waves spreading through this nothingness, as if something massive had just moved past. Scientists offered explanations, of course. Plasma waves can sometimes be triggered by energy from distant stars, or even shock waves traveling through the interstellar medium. But those events usually look messy, irregular, violent, without symmetry. This was different, too smooth, too precise, and that's why it shook researchers. Voyager 1 wasn't supposed to be the probe that changed our understanding of deep space. It wasn't supposed to be more than a relic, but with its outdated instruments and its faint transmitter, it may have stumbled onto evidence of something that isn't supposed to exist, an object moving through the void, leaving behind a wake that shouldn't be there. And then, things got even stranger, because the plasma disturbance wasn't alone. Almost at the same moment, Voyager's magnetometer, one of the few surviving instruments still alive, registered a sharp deviation. The magnetic field around the probe shifted suddenly, then snapped back to normal. It wasn't noise. It wasn't a glitch. The timing aligned perfectly with the plasma event. 2 instruments, working independently, caught anomalies at the exact same instant. That detail is critical. If it had been random cosmic rays or simple background interference, the readings wouldn't have matched up so cleanly. Instead, it looked like a mass, something with real physical presence, had brushed against the invisible magnetic fields of interstellar space. Natural bursts of radiation were quickly ruled out. What Voyager saw was consistent with an object actually passing by. Inside NASA, the reaction was divided. On one hand, the team had seen anomalies before, weird spikes in data that later turned out to be technical glitches or corrupted signals. Engineers were cautious. They went back through the recordings again and again, hunting for evidence of a malfunction. Could the transmitter have flickered? Could the data have been scrambled as it traveled billions of miles back to Earth? Every possibility was tested, but nothing fit. The instruments were confirmed to be working normally. Telemetry checks showed no corruption. And when solar activity logs were pulled, there were no flares, no bursts, no events that could have influenced Voyager during that window of time. Slowly, engineers were forced to admit the uncomfortable truth. This wasn't a glitch, it was real. That conclusion opened the door to an even bigger dilemma. If it wasn't an error, then what exactly did Voyager detect? The first theories leaned toward natural explanations. Maybe a shard of interstellar dust had passed close by. Space is full of microscopic debris, tiny grains that drift between stars. But dust wouldn't create such a strong, organized disturbance in both plasma and magnetic fields. The readings suggested something much larger. A comet fragment was also considered. Our solar system regularly captures icy visitors from the Oort cloud, and fragments from other star systems could, in theory, drift past Voyager's path. But when astronomers ran the models, the trajectory didn't match. The disturbance had the signature of something massive enough to alter its course, and comet shards don't suddenly change direction. Then came the meteoroid theory, a rogue rock speeding through the galaxy. It was plausible, but again the data didn't fit. No reflective signals were detected. No visible trace of a solid object was picked up. Whatever had passed Voyager was dark, completely non-reflective, absorbing rather than bouncing back radiation. And even more puzzling, the readings suggested an apparent course correction, as if it wasn't just drifting, as if it had changed direction deliberately. That was the detail that made scientists uneasy. Dust doesn't change course, rocks don't steer, comets don't slip quietly past without leaving a visual trail. None of the natural explanations fit what Voyager had just recorded, and so the old spacecraft, with its dying instruments and faint transmitter, forced NASA into an uncomfortable position. Something had passed by, something big enough to bend plasma and magnetic fields, something dark, invisible to reflection, and possibly something that could maneuver. And then the evidence took an even sharper turn. The data didn't just hint at the possibility of motion, it revealed it. A flicker, a bend, a subtle shift, as though the thing had nudged itself with intent. Space debris doesn't do that. Rogue asteroids don't make mid-course corrections. Yet what Voyager's instruments picked up suggested the object wasn't just drifting, it was adjusting. Controlled motion, purposeful, almost like a pilot had tapped the brakes in the middle of nowhere. And then came the energy mystery. Normally, rocks reflect, dust scatters, even frozen comets throw back sunlight like tiny mirrors. But this thing, it swallowed light. It absorbed plasma waves like a cloak, leaving almost no reflection at all. Its stealth was not accidental. It felt engineered, a design to vanish into the void. Some at NASA whispered about active camouflage. Others speculated something more radical. Propulsion, not by rockets, but by the universe itself. Plasma sail technology, riding the particles of deep space the way an ancient ship rides the wind. An idea humans only toyed with in theory suddenly looked real, and it wasn't coming from us. That raised the chilling question. What if this was humanity's first brush with an alien artifact, and it passed us by without ever stopping? The parallels were impossible to ignore. In 2017, astronomers spotted something that didn't belong. A strange shard whipping through the solar system at impossible speed. They called it Oumuamua. It tumbled, it spun, and it refused to behave like any asteroid or comet ever recorded. Some said it was hydrogen ice, others said a sliver of rock from another star. But one voice, Harvard's Avi Loeb, broke ranks, suggesting it might be alien tech, a probe sent from elsewhere. The mainstream laughed until the math refused to add up. And suddenly, Oumuamua became the most controversial visitor in modern astronomy. Now the Voyager readings brought those suspicions screaming back. The same unnatural acceleration, the same refusal to conform to physics as we know it. But this case was stranger, because it wasn't based on telescope data at a distance, it was direct. Voyager felt the disturbance in the plasma sea itself, as if something had brushed past its sensors, like a ghost in the dark. Oumuamua was debated from afar. This was intimate, close range, undeniable, which begged the darker question, if both objects behaved the same way, then maybe Oumuamua wasn't a one-off. Maybe there are more of them, silently drifting through our backyard, invisible until they choose otherwise. That possibility turns the entire story of space on its head. We like to imagine interstellar space as empty, a desert of dust and darkness. But what if it isn't? What if it's alive with motion, not of stars or rocks, but of machines? The old Fermi paradox, if the galaxy is teeming with life, why haven't we heard from them, suddenly takes a sinister twist. Maybe the silence isn't absence. Maybe it's strategy. What if civilizations don't broadcast beacons into the void because only reckless species do that? What if the smart ones move unseen, traveling on plasma currents, watching, recording, but never calling attention to themselves? And what role does Voyager play in this hidden theater? To us, it's a message in a bottle, drifting with a golden record of Beethoven and greetings in 60 languages. To them, it might be nothing at all. Maybe they ignored it, dismissing it as primitive, like humans would ignore a paper boat floating past an aircraft carrier. The thought gnaws at the imagination. The galaxy could be full of quiet observers, civilizations so advanced they slip past us undetected, seeing us long before we ever realize we're not alone. Yet even without invoking other minds, the mystery deepens. Because the data Voyager returned didn't just stir questions about who might be out there, it forced scientists to rethink what space itself really is. For over a century, physics has described the cosmos as emptiness governed only by gravity and radiation pressure. But Voyager's strange readings suggest that picture may be incomplete. Imagine the galaxy not as a calm void, but as an ocean of hidden rivers, interstellar corridors, invisible highways through which energy, matter, and even rogue worlds may drift. Just as ancient sailors once caught trade winds that carried them across vast oceans, objects in deep space might be swept along streams of plasma and magnetic fields, bending their courses in ways gravity alone can't explain. This isn't science fiction. Astronomers have already detected flux ropes connecting Earth's magnetosphere to the Sun, filaments of plasma threading through the solar system like taut wires. If such structures exist on a galactic scale, then Oumuamua and Voyager may have brushed against these hidden channels, evidence of a vast uncharted network of cosmic currents. The implications are staggering. Space travel could someday mean more than just thrust and fuel. It could mean hitching a ride on these magnetic winds, navigating the galaxy the way Polynesian explorers once read ocean swells. The new frontier of exploration may not be telescopes peering at light, but instruments listening for ripples in plasma fields, tracing the faint murmur of these currents as they guide objects across light years. Future missions could deploy swarms of probes tuned not to gravity, but to the whisper of magnetic tides, slowly building a map of the hidden skeleton of our galaxy. And in a way, that map has already begun. Because Voyager is not just a machine of science, it is also a messenger. Strapped to its side is the Golden Record, a time capsule of humanity's essence. Greetings in 55 languages, photographs of our world, diagrams of DNA, the sound of a kiss, the crash of thunder, and the music of Bach and Chuck Berry. It was Carl Sagan's dream, a bottle tossed into the cosmic sea. Now imagine the poetry of what just happened. For 46 years, Voyager has drifted outward, carrying our voice into silence. And suddenly, something brushed past it. Was it a rock? A shard of alien technology? A traveler from another star? Whatever it was, it may have passed close enough to sense that golden disc, our coded self-portrait, waiting in the dark. Voyager's journey has already given humanity countless firsts. The first close look at Jupiter's volcanic moon Io, the first photographs of Saturn's intricate rings, the first family portrait of our solar system from the edge. And now, perhaps, it has given us one final gift, proof that the void is not empty, that the silence of space hums with hidden motion. The golden record was meant as an introduction, but Voyager itself may have become the invitation, a sign that we are not alone in the currents of the galaxy. And when that possibility surfaced, the human response was anything but calm. Fragments of the Voyager disturbance leaked into the public domain, and the reaction was immediate and divided. Inside the scientific community, it sparked a rift. Some astrophysicists saw uncanny parallels to Oumuamua, the mysterious cigar-shaped object that slipped through our solar system in 2017, bending trajectories in ways gravity alone couldn't explain. To them, Voyager's data wasn't just noise, it was a second data point in a growing mystery. But skeptics fought back. They argued the probe was old, its instruments battered by cosmic rays, its power nearly gone. Data-chasing ghosts, one prominent critic called it, dismissing the anomaly as nothing more than system fatigue. The debate might have stayed buried in academic journals, if not for the public. Because when ordinary people heard that humanity's oldest, weakest probe might have brushed against something unexplained, the imagination of the world ignited. Social media erupted with speculation. Was Voyager touched by an alien ship? Did it skim an invisible galactic highway? Or had it, in its dying days, brushed the edge of another civilization's signal? The irony was brutal. While billion-dollar telescopes and state-of-the-art observatories scanned the skies for decades, it was an aging relic from the 1970s, a probe running on less power than a household light bulb that stumbled onto the most tantalizing clue yet. It forced a sobering truth. Sometimes history isn't made by our most advanced machines, but by the ones we've forgotten. And that realization pushed humanity to ask a deeper question. If Voyager, blind and weak, could catch a glimpse of something extraordinary, what might we find if we actually built machines designed to listen for it? The answer soon followed. Engineers began speaking openly about probes that would go far beyond chemical rockets and gravitational slingshots. If Voyager was a message in a bottle, humanity now wanted fleets, a new generation of Voyagers, crafted not as relics, but as explorers built for the hidden currents of the galaxy. Proposals began stacking up. NASA's Interstellar probe 2030, a nuclear-powered craft designed to break through the heliopause faster and farther than Voyager ever could. The Breakthrough Starshot project, backed by billionaires, proposing to launch swarms of tiny laser-driven sails that could reach Alpha Centauri in just 20 years. And in China, state scientists quietly sketched plans for long-range probes that might ride magnetic currents, carrying AI-guided systems capable of repairing themselves on journeys lasting centuries. These weren't just ships built to look for light. They would hunt disturbances in plasma, magnetic fields, and what some physicists call dark signals, subtle ripples that might betray forces we don't yet understand. Where Voyager stumbled by accident, these missions would listen by design. The philosophy shifted. Space wasn't just emptiness anymore. It was a sea with hidden tides, crosswinds, and currents we had barely begun to chart. And just as ancient sailors once pushed wooden ships into unknown oceans, we now stand on the edge of sending machines to ride those invisible waves. Every generation builds vessels to carry its questions into the dark. But this time, the questions feel heavier. Because if there really are currents out there, then maybe, just maybe, we aren't the only sailors. And that is what makes Voyager's twilight so haunting. Its nuclear heart is cooling, its power is fading. Soon, its voice will fall silent forever. Yet before that silence, it delivered one last anomaly, a puzzle that will outlive its signal. And in that sense, Voyager has done what no other spacecraft has ever achieved. It has left us not with an answer, but with a question big enough to change how we see exploration itself. Scientists are already sketching designs for the next generation of deep patience probes. Unlike Voyager, which raced outward and burned through its strength, these probes may drift slowly, sipping power, listening not for radio waves alone, but for the faint shiver of magnetic storms in interstellar space. They will not just follow light, they will follow ripples. The mission will not be speed, but endurance, instruments that wait, watch, and whisper back across centuries. Because if Voyager could sense something move near it, then what else is moving just beyond our sight? What hidden highways cut through the dark, waiting for us to discover them? The galaxy may not be chaos after all, but order, structured, patterned, alive with invisible currents. And that changes everything. For decades we looked up at the stars and thought only in terms of distance. But now perhaps the true measure of exploration will not be how far we can travel, but how well we can listen. Voyager's fading heartbeat has given us that challenge to hear the quiet signals, to follow the hidden rivers, and to finally understand that the universe is not still. It is moving, always moving. And the only question that remains is, are we moving with it, or have we only just begun to notice? If something brushed past Voyager, then perhaps the darkness around us is not empty at all. Perhaps the void is crowded, alive, waiting. And if that is true, then humanity's story has only just begun. If Voyager could sense the unseen, imagine what you could discover by staying curious. Hit that like button if this mystery blew your mind, comment below with what you think is really out there in the void, and subscribe to join us on every journey into the unknown. Don't miss the next signal. The galaxy is moving, and so are we.